Now here's an interesting aside. Voltage in PEMF and voltage in almost all chronic diseases are characterized by a low cellular voltage. And like we said, voltage is stored energy. So in the case of a cell, voltage is stored across the cell membrane of every cell that gives cells energy to do work. And this is due to the cells having a net positive charge on the outside of the cell and a net negative charge on the inside. Dr. Otto Warburg is one of the first to show that when our cellular voltage starts to drop, our health starts to drop, and we get sicker and sicker as the voltage gets lower and lower, to the point that if our cell voltage drops below 15 or 20 millivolts, we can get cancer or some serious illness. Now, PEMF therapy acts like a cellular battery charger by sweeping pulse magnetic fields across the cell membrane, which moves charges and helps to recharge that cellular voltage. In essence, PEMF therapy really is like a whole body battery charger, which charges up your cellular voltage. And again, voltage is a measure of stored energy. Okay, so we move charges apart. How do we keep them separated? Well, in the cell membrane, it was the cell membrane that kept them separated. And what this is a capacitor. A capacitor is a device that can store charges much like a water tower stores energy by elevating or separating water from the ground. Now, a capacitor consists of two conducting plates separated by an insulating layer called the dielectric, which we'll talk about more later. The stored charge is proportional to the potential difference or voltage between the plates. And the constant proportionality is called the capacitance, which is measured in farads. And capacitance equals Q over V, or charge divided by voltage. Capacitors with an air dielectric, which is just air in between, have a capacitance equal to the area of the plates divided by the distance between them. So larger plates closer together are going to have a greater capacitance than small plates further apart. Now, the cell membrane of each of your 37 trillion cells does act as a capacitor that can keep charges separated until the energy is needed. This is how cellular voltage is stored. And typically, the cell uses ATP through the sodium-potassium pump to charge up that cellular voltage. But like I said, PEMF therapy can also help to charge up the membrane potential without using up precious ATP storage. So it always takes energy of some force to separate charge, but once separated across an insulator like the cell membrane, there's energy stored that can do work when needed. I won't derive it, but the energy stored is equal to 1/2 CV squared. That's 1/2 the capacitance times the voltage squared. So it takes work to separate charge in a capacitor, and once separated, the capacitor stores energy. So separating charge is one of the keys to energizing not only electronic devices, but life itself. In fact, the more I study biophysics, it just may be the key to life, especially in the efficiency that life is able to separate and store charge.